mechanical engineering graduate from the United States, and I'm currently here with Windade as the engineering intern. The reason I came to Peru to work for Windade was because I wasn't sure what I wanted to do after I just graduated, so I figured I might as well go and do something that I was very passionate about, and which is wind energy, and do it for a nonprofit like Windade in a developing nation like Peru, because I think it's a great opportunity to put what I've learned in school to good use. Now, as a long-term volunteer with Windade, or just as an intern in general, you are encouraged to find a long-term project to do that is also, it works in conjunction with what Windade is trying to accomplish. So after spending my first month in the workshop, I learned how Windade utilizes both carbon fiber and fiberglass for their blade. Now, through my studies and through internships, I've come through a lot of experience working with composite material. And what I realized upon coming here to Windade is that Windade can get rid of their carbon fiber and replace it purely with fiberglass. Doing so would mean that Windade would be saving a ton of money. Normally, carbon fiber is around 7 times more expensive than fiberglass. So if I can cut that cost out completely, then we can spend a lot more money on other projects and helping other communities. But to do so, I have to make sure that the fiberglass matches the strength and the stiffness of the carbon fiber. So what we have here is the first step of my project, which is creating test pieces to perform strength and stiffness testing on a combination of different laminations using carbon fiber, fiberglass, and chalk strand fibers. What we have here is I'll just be making a simple wet layup on this glass plate, and in the end I'll have a couple of these pieces set up, and we'll take them and do multiple tests, including strength tests and stiffness testing. So what we have here is the polyester resin we use to make our laminations and the resin we use in our blades. What this is the peroxide, this is the catalyst agent. So once I put this in here, I'm going to have about 10 to 15 minutes of work time with this resin. This is what makes the resin start to cure, and this is what makes it hard. It has now been 24 hours since I finished the lamination. I have just taken these sample pieces off. So what we have here are the 2 pieces utilizing one of carbon and the second of fiberglass. Now, the process in which I did this was easy. I first painted a layer of resin on the glass sheet and then put the first ply of composite down. I then painted a second layer of resin and placed the second layer of composite. I repeated this process until I was finished with all my plies, and then I sealed it and let it sit for 24 hours. Now, I gotta trim it up, cut it into little pieces, and we're gonna throw it into our testing device. So now that I have cleaned, trimmed, and cut up those test samples into individual test pieces, I'm going to put each piece into our 3-point bend test. Now, the point of this test is to measure the strength and the stiffness of each member. And the result of this is going to tell me whether I have matched the strength and stiffness of carbon fiber with the layers of fiberglass. Now that I finished my testing and I proved kind of what I was thinking, that I can match the stiffness and the strength of fiberglass to that of the carbon fiber, we are now going to put that into actual practice. So here I have Sophie and Mike who are helping me with the layup of the blade. So we're just taking the first layer of fiberglass and wrapping it around the blade. So they'll finish wrapping this. We'll put it in the resin mold. We'll put just another final layer down. We'll close up the mold, inject the resin, and we'll see how it goes. So what we last saw was the volunteers wrapping the blade in fiberglass. Put the blade here in the mold. We sealed the mold, and yesterday we injected it with the resin. What we're doing right now is we're opening the mold, and we're going to see how the blade comes out with the fiberglass and resin mixture.
Yeah.
So we have removed the blade from the mold, and this is what we get after cutting it off, trimming it, and sanding it down. So as you can see, you know, it's not perfect. There's always little deformities that we have to touch up with some more resin. But generally, what came out seems to be a pretty good blade. So the next step, sand it down some more and paint it, and we'll be installing it in Playa Blanca next week. So here it is, all touched up and painted. She made her way to Playa Blanca, and now we're going to install her here at the future workshop for the last installation of Wind Aid here at Playa Blanca.